Okay, let's take a look at 3. I love these problems. I love it when they give me a graph because it is like it's normally going to be a strictly conceptual type problem. So, here we go. Conceptual. Let's see if we can do this. It says the graph of f above consists of 2 straight line segments. Now, if you're anything like me, whenever it tells me something and it's not on my picture, I label it. So, I want to label this right away so I know that this is f. Okay, this is f. All right, now it says let G equal this stuff. And if you're new at this, you see this and you might like get a little scared because you're like, oh dang it, I have to remember what everything means right here. All right, and then it gives you a -3 to 5, which makes sense. -3 to 5. Okay. Find the values of x for which G has a local maximum. Justify your answer. This is where your conceptual understanding of what this is really comes into play. Because actually, when I think about it, I don't like this label f. What is f in comparison to this guy? All right, so you guys know f, f prime, f double prime, right? You guys understand those? Okay. F prime talks about slope. Now, we know something about extreme values. We did a lot of work with this stuff. If you have an f, let's use a different letter. Let's use g. Okay, if you had a g and g prime, and you wanted to find the extreme values of g, you know that you can take g prime and set it equal to 0 to find out where you have like this or you have this, because the slope right here is 0, right? And the slope right here is 0. You guys with me? So, if I wanted to find where a local maximum is on a function, I just need the derivative, right? I just need the derivative of it. What is g prime in this situation? FTC2, guys. If you knew FTC2 and you read this right here, I'm hoping you saw local maximum and you immediately thought, I need the derivative and I need to set it equal to 0. Did you think that? Okay, but there's a problem. Because you're going and you look at this and you're like, okay, but there's no function there. This just says f of t. This is bulk. I shouldn't say that, but this is, like, you might get frustrated. I don't know. But let's write it out anyways. What is g prime right now? Let's see. Let's say you take the derivative of it. You get g prime of x equals, don't you just ignore this 2, because that's the constant. A derivative of a constant is 0, so by 2. And then I plug that x into the f, right? So what does this say? It says that g prime equals f of x. So this actually is a dumb label. This is g prime. Now, oh, it's golden. Now I know what g prime is. I can find my local max and local mins. G prime, okay, local maxes and local mins is where the derivative equals 0, right? Now, I just said that this graph is g prime. Could you guys tell me where it equals 0? Equals 0 right there at 0, and it equals 0 right there at 4. Those are your critical values. Now, how do you know if it's going to be a maximum or minimum? How do you know if this point right here on my g function is going to be a maximum or minimum? Now, this line right here is not g, guys. That is g prime. We don't know what g looks like. We might be able to figure it out, but we don't have to right now. What is that, though? Is that going to be the maximum or minimum? Is the slope positive and then negative, or is it negative and then positive? It's negative and then positive. Like it's below the x-axis, then it's above the x-axis, right? So right at 0, I'm going to go ahead and write my notes right here. Right there, that's going to be min on g, right? On g of x. That's going to be the min. And what is this one going to be? Because it's above the x-axis, then below the x-axis, that means it's increasing and then decreasing. That would be your local maximum, right? This would be the max on g of x. All right, so we just found it. That's your answer. Now, how would you justify your answer? Well, you would say something about it being above and below the x-axis and how that correlates to g increasing, decreasing, and that's how you would write it out. Okay, I'm not going to take time to write it out because I want to get through this really quick. Okay, so we're good with that one. B, it says, what is the maximum value of g? Whenever it says just maximum value, it's talking about the absolute maximum. Whenever it says just max, you have to assume it's talking about the absolute. What is the absolute maximum value of g on this interval? Now, forget integrals right now. Let's go back to derivatives, all the way back to 3 months ago. If you had to find the absolute maximum, there's two things you need to test. Critical points and the boundaries, the endpoints. You need your critical values, or like where they're at, the critical values, the x values, and you need the endpoints. So what are our critical values? Well, they're right here and right here. And what are our end values? Right there and right there. So you have to test your endpoints and you have to test your critical points. Now technically we're supposed to check all of these x values, but I'm not going to check this one because I know that's a local min. A local min can't be an absolute max. And so there's really only 3 values I have to check. I have to check -3, 4, and 5. How do you check it? You go like this. So this is B, right? Yeah, we're on B. You're going to go g of -3, and you're going to go g of 4, and you're going to go g of 5. And you're going to plug those in. So this guy right here, I need that 2 back. 2, you come back to me. All right. When I plug this in, it's going to look like this. I go from 2 to 3, wait, -3, and then that's going to be of f of t dt. Do you guys know how to find that if you're given this graph right here? I hope so. Do you guys know what integral means? You guys told me yesterday. It's the area underneath the curve, right? The area between the curve and the x-intercept. I'm sorry, intercept. The x-axis. So you're looking for, see, here's 2. We're going this way, which you guys also know that means it's the opposite, right? You need to find the area of this and the area of this. Now those are opposite areas. One's positive and one's negative, correct? If I add those together, they're going to, in a sense, cancel each other out. Now that first one, this negative one, looks bigger than this positive one, correct? And if I went from -3 to 2, my guess would be that this would be a negative area. But we're not going from -3 to 2. We're going from 2 to -3. We're going the opposite way, which we don't like. You shouldn't like that. You should like that your lower bound is always the smaller number. Right now our lower bound is +2. We don't want him. So do this. Go -3 on the bottom, 2 on top, and then figure out your area. Once you figure out the areas between this one and this one, you combine them and then slap the negative on it, and that's your answer. Okay? So let's do it. We can do it really fast in our head, yeah? So I don't have to write as much. We're starting at -3 and we're going to 2. Let's find the areas of this. What is the area of this? See, that's 1, 2, 3, right? There's 3 is the base, and what's my height of the triangle? It's 6, right? So we have 3 times 6, which is 18, and then I'm supposed to divide it by 2. 1/2 base times height. That's how you find the area of a triangle. So 18. That'd be -18 divided by 2 is -9. Plus, now I'm going to add this area right here. That would be 2 is the base and 4 is the height. 2 times 4 is 8. Then divide that by 2. So this equals, whoops, I almost forgot, negative. Okay, this is going to equal -5, and what's -5? +5. So this is my value for -3. Okay, now what I'm going to do is I'm going to do the same thing for 4, and I'm going to do the same thing for 5, and see which one is the biggest, so we know our absolute maximum. I think, and correct me if I'm wrong, because I want to save time. I don't want to do all of them, because you guys can do them. Is 5 the biggest one? I think it is. Yeah, when you do these ones, when you plug the 4 and the 5 in separately and figure those out, you're going to get something less than 5. So now you know that your maximum value is 5 at -3. So it says, what is the maximum value of g of x? You would say 5. And your justification for your answer is all your work.
Is it -5 or 5?
It's +5 because I switched the interval right here, and when you do that, you have to change the sign. So instead of going from 2 to -3, I like thinking going from lowest to highest. And if I just went from lowest to highest, that would be a negative area because this one's bigger and that one's smaller, right? The positive is smaller. And so that's what negative 5 is. But then I had the negative right here because I switched the order, right? And so I have to go negative 5, which is positive 5. So our answer for letter B is 5. I mean, once you figure out these ones right here, I'm not going to do that right now, but we know that the answer is 5. That's the y value. So I guess you could write negative 3, 5 is where your maximum is. The negative 3 gives you the location, and this is actually what your max is. Whenever it says max value, it's talking about the y. All right, so the last question for this says, on what subinterval of this is the graph of G concave up? Justify your answer. Concavity. Oh, you know what it's busting out now? It's trying to see if you know what G double prime means. Whoops. Do you guys know what G double prime means? G double prime tells you the acceleration of G, correct? G double prime tells you the slope of G prime. Okay, you still with me? Now it says on what subintervals of this is the graph concave up. Concave up would be where this G prime is increasing. Because wherever it's increasing, that's where G double prime will be positive. So this is G prime. It's increasing here. If I were to graph G double prime, wouldn't all of this be above the x-axis because it's positive? If it's above the x-axis and it's positive, it's concave up in that area. Okay. Now you would have to use words to justify your answer here, but all you need to say pretty much is that between negative 3 and 2, G prime is increasing. So negative 3 and 2, G prime is increasing, therefore G is concave up between negative 3 and positive 2.